Have you ever wondered why chemistry feels difficult to grasp? Imagine you travel to a new country or new city where you don't know the language. Every word sounds confusing. But as soon as you start learning their language, things become simple and easy. In chemistry, it is exactly the same. If you understand the languages of chemistry, it will be easier for you to interpret, navigate, and explore more effectively. Again, understanding the right language with the right meaning is equally important, otherwise it may create more confusion later. First ask yourself, do you know the difference between an atom and an element? If it is not clear, then you might need to revise the languages of chemistry again. So let's begin the journey together. In chemistry, the objective is to understand matter and how it transforms. So to understand matter, it is important to be familiar with various terms associated with it. Matter is anything that has mass and occupies some space. Except space, everything around us is matter. Air is also matter, even though we cannot see it. In this video, we will try to decode the language associated with matter. We shall now start with element. An element is a fundamental chemical identity that is preserved in any chemical reaction. For example, sodium is an element. And it is called sodium even if it chemically combines to form other substance such as sodium chloride. In NaCl, we say it has sodium and chlorine. Here, neither sodium nor chlorine loses its identity. Similarly, in NaOH, we say it is made with sodium, oxygen, and hydrogen. So sodium preserves its identity in both the compounds. Hence, it is the element. But we cannot tell NaOH to be an element, because it can be transformed to NaCl, and the identity of NaCl is completely different from NaOH. Here, the entity NaOH loses its identity through a chemical reaction. As of now, we have a total of 118 elements, of which 94 are naturally occurring and 24 are synthetic elements. All the matters that we see around us are made with these 118 elements. And in every matter they preserve their identity. One element can never be converted into another element by chemical reactions. You can never ever convert a sodium into a chlorine via chemical pathways. While element is the fundamental identity, an atom is the smallest individual unit of an element that carries the identity and retains the chemical property of it. If we go on breaking an element, we will end up with the smallest unit, which cannot be further broken and if broken, will lose its identity. Suppose we have an iron element and we break it and ultimately reach to a point where it cannot be further broken. If we break it, then it will no longer remain as iron. It will release subatomic particles like protons, electrons, and neutrons. The identity of iron will be lost. Now coming to molecule. Molecules are made up of atoms. A molecule is a discrete group of two or more atoms held together by chemical bonds and capable of independent existence. For example, H2 is hydrogen molecule. There is a chemical bond between two hydrogen atoms and it can exist independently. H2O is also a molecule that is formed by the two different atoms bonded chemically. CO2 is also a molecule. But NaCl is not a molecule, because NaCl does not exist as an isolated NaCl unit. If you compare it with CO2, each CO2 exists independently. But in NaCl, both Na+ and Cl- form a continuous three-dimensional ionic network. Similarly, all other salts like KCl and CaSO4 are not molecules. With this definition, all other ionic solids are not molecules. KMnO4 is not a molecule. Even MnO2 is not a molecule, because their independent existence is not possible. They form an extended crystal structure or network solid. Similarly, neither graphite nor diamond is considered a molecule. In diamond, each carbon atom is covalently bonded to 4 other carbon atoms in a giant 3D network. There is no discrete diamond molecule that can exist independently. Similarly, graphite forms giant two-dimensional sheets. These are giant covalent network solids. In CO2, the formulas represent the true independent picture of its existence. But MnO2 represents a formula unit. There is another class called compound. Compounds and molecules are not the same thing. A compound is a substance formed when 2 or more different elements combine chemically in a fixed proportion. A compound answers how many elemental identities are present, whereas molecules say whether it exists as a discrete independent unit. Let us see how molecules are different from compounds. Oxygen is a molecule, but it is not a compound as it is made up of a single element, which is oxygen. Similarly, ozone is also not a compound. It is made with 3 oxygen atoms. But water, which is H2O, is a molecule as well as a compound, because it is made with 2 different elements and exists as an independent unit. However, sodium chloride is a compound, but it is not a molecule. Sodium chloride made with 2 different elements, sodium and chloride, that makes it a compound, whereas it does not exist as an independent unit, so it is not a molecule. Diamond is neither a compound nor a molecule, as it is made with 1 element, which is carbon, and it does not exist as a discrete independent unit too. In short, molecules possess independent existence and can be made with similar atoms, whereas compounds must be made with 2 or more different elements and may or may not have independent existence. Compounds can be broadly classified as ionic compounds, like NaCl and KCl, and molecular compounds like H2O and CO2. In the next video, we will cover other definitions such as molecular and empirical formula, atomic mass, average atomic mass, and relative mass, and other related terms.